So here we have MATLAB. So what we're going to do is we're going to explore how to use ODE45 to solve differential equation numerically. So first, let's just say what our differential equation is going to be. We can do this in here. This is my script. So the y prime is 2ty minus t. So I can solve it symbolically. So I'm defining y as a function of t. Oh, it's sims. I apologize. And so you have sim yt, and so you can solve it numerically using dsolve. So I want the derivative of y to be equal to 2 times t times y minus t. And so I have a solution here. See, this C1 here is going to be our arbitrary constant. It comes from however method you solve it. Basically, in order to actually get a specific solution, you need to use the initial condition. Y of 0 is 1. So I can feed that in here too. Y of 0 is equal to 1. And then I have the solution here. So here is the solution. And this is given by some kind of function. So let's define an anonymous function. So it's going to be a function that takes, I apologize. So y is going to be my anonymous function. It's going to be the actual solution. And what it's going to do is going to take in the value of t, and it's going to spit out the exact solution. So actually, to illustrate something that can go wrong, I'm going to forget this, and I'm just going to copy this in. E to the t squared over 2. The first error I get is that it doesn't recognize e, and the reason is e is just a variable. E is not being treated as a number. So what you have to do is actually use the exponential function. E is just going to be a variable. It can be anything. You can call anything you want e. Like I used y to represent a function, I can use e. It doesn't recognize e as a number like pi. You have to do something else. So here is yt, and this is just some expression. And this right here is not a function, this is an expression. And the reason is I define t up here symbolically. So t is defined symbolically, so this right here makes sense. It's already defined. But if I clear t, now I remove t from the workspace. So t is not over here anymore in the workspace. So what you see is that when I do this definition here, I'm going to get an error because it doesn't know what t is. I didn't tell MATLAB that t was an input variable into this function. So the way that I do that is I do @of, and now I've defined it symbolically. So this is a function handle. This is a way that I can give MATLAB a function without telling MATLAB run this function. It's just like if you have something like Alexa, and Alexa is listening to your conversation while you're speaking, and you say Alexa in your conversation, Alexa might pick it up and think that you're talking to Alexa. So basically what a function handle is a way of doing when you define a function like this and other functions that you have, like if I have ODE45, it thinks I want to run ODE45 if I just call it. But if with the @ symbol, it understands that I'm just referring to ODE45. I'm not actually using it. I'm not telling MATLAB run ODE45. And speaking of ODE45, let's use that. So we don't know how to use it, so let's just ask MATLAB to help us. What does ODE45 do? So this is just some information. This right here is a little too general to appreciate. It's best to see by an example, but this is a general place to start. I go to documentation, and this right here has an example, but let's just use our example up there. So what we're going to do is, if you call ODE45, what you need to do is pass it in 3 things for the basic functionality. You need to pass it a function. You need to pass it some length of time it needs to solve the differential equation on, and you need to pass it an initial condition. So what function should we pass it? Well, we haven't defined a function, so how could we define a function? So this is going to be our function of 2 variables, t, y. It's important that you have them in the right order. 2 times t times y minus t. So this is a function, And I want to illustrate that if you do 1, 2, and f of 2, 1, they are different. And so this is very important to keep in mind that t is always going to be treated as the independent variable. The first argument is going to be treated as the independent variable. So if you were to define f in the opposite way, when you call ODE45 or some other ODE solver, it depends on the exact implementation of it. But in terms of ODE45 and Quiver 244, like on the previous lab, this thing right here, y, is being treated as the independent variable. So you're thinking t as a function of y, which is not at all what you want. So you actually want to make sure you have them in the right order. So here's our function that we're going to use for our differential equation. So we go back up to ODE45, and we are going to call it with the function f. Next thing we need to do is pass it a time interval. There's 2 ways to do this. Let's do the simple way. One way you do it is you can pass it the whole interval like this. It's an array. The first one is the beginning time, and the second one is the ending time. And ODE45 is an adapted method. What that means is it's actually going to pick the time interval and timestamps in a way that best optimizes certain things. So it has certain errors built into it. I think it's mentioned up here. There's some kind of errors it's allowed to do. No, it's more in the, oh, here it is. Yeah. So using a default relative error of e, or so 10 to the negative 3, and an absolute default tolerance, 10 to the negative 6. So basically, these are sorts of errors that it's going to allow. And if you use options, you can actually change these errors, make them better, make them worse, things like that. And here are a bunch of other ODE methods. And in this right here, the important thing is that when you have the, apologize for that. So if you have this interval here, if you don't tell it exactly what points to look at, then it's going to pick its own points. And the other thing you need to pass it is an initial condition. So we had y of 0 was 1. So we're going to pass it the initial condition 1. And it seems that what it's doing is it's picking this point right here and using it as the initial time. So here's ODE45 running. And I don't know if you can see this. So let me share the figure. And you see a solution right here. You see that it graphed a bunch of points and it just automatically generated all this stuff. It didn't tell you anything about the numbers, it just graphed them. If you don't want that, what you should do is tell MATLAB exactly what you want. So we should go up here and run it like this, where you give it the time intervals and values at those time intervals. So let's go back down. So let's say t list y list. Oops, I accidentally hit enter. And it generated a ton of stuff. So what does it have here? So what it did is it calculated a whole bunch of points. So those points that we just saw graphed, those are these points. 0, 1, that's the initial condition. And then it calculated a whole bunch of time points and a whole bunch of y points, and it lists them vertically. And so you can see these numbers. But one thing you might want to do is graph them, where you might want to compare y to it. So how about we go over here to this script over here and we start plotting some stuff. So we have y. So this right here is a script. And what it is, it's just a whole bunch of code that MATLAB is going to run all at once. So basically, I'm running it over here in the command window, storing things in the workspace over here. But as long as I don't write clear all or something like that, where I clear everything out that I've already done, it's still going to assume that all that's been done. If you look at the beginning of your labs, that actually has clear all and CLC and another command to wipe everything clean before you run the whole script. That's to keep any errors from coming from something else that you did previously. But because I don't want those errors to go away because I didn't do anything wrong. Nothing that I haven't fixed, like this is a mistake. So what I can do is I can plot. So let me just do, hold on. So I don't remember exactly all the plot stuff. I mean, I do, but I'm just illustrating it. I'm going to ask MATLAB for help. How are all the different ways I can plot things? So the things I was looking for were these colors and nice designs. So I know that if I plot the t's, t list, y list, this is going to plot all the numbers that MATLAB generated using ode45. But I also want to I want to draw it in a way. So because I'm thinking of them as individual points, maybe I'll use stars. So star. And I like sign, so let's use C. So now if I run this, it's going to generate those things. Okay, so I have my first one here. I don't need to put that. Let me just make a little more space. This is my first plot. I'm telling MATLAB to hold on so I can plot the actual solution. And what is the actual solution? Well, I have t list. And I want to apply my actual solution, the solution to the t list. And before I start, I just start figure. Just it's a good habit, just in case you have anything before. So let's see what happens. Is there an error? There is an error. So what it did, let me show you what it plotted. It plotted this. And these are actually the solutions that we got from ODE45. So I don't see the actual solution. So we're going to have to go back and see what happened. So the thing that happened is we have to look at this error. Error using arrow. Incorrect dimensions for raising matrix to a power. Check that the matrix is square, et cetera, et cetera, et cetera. It says the error was in this thing. This is our definition of ysol. And it occurred in this calling of plot. So what happened is we call plot. This line, we got to line 5. It was fine with this. It was fine with this until we plugged in t-list into ysol. And the reason is that if you have t-list, it's a long list of numbers. If you square it, it doesn't understand what that means. If I do t-list times, because remember the solution ysol, what is ysol? It has a squaring in it. So why aren't you allowed to square a matrix? I mean, an array. Basically what it does is it treats this as a matrix. And in terms of matrices, there's a certain meaning for what it means to square a matrix. We'll talk about that later in the course, but squaring a matrix is only a thing you could do if it's a square array, if it has the same number of rows as columns. And since that isn't true for this, because it's just a long array with many rows and one column, this is not allowed. If you want to square each entry, you have to put a point. And now it's square each entry. So for instance, to see it a little more clearly, so you have TS, a whole bunch of T's, 0, half, 1, and you TS point squared. And you see that that's these numbers squared. So in my solution for ysol, my definition, I mean, go back up and see here for F, it somehow this worked out too. This was fun. You got to be careful though. It's usually good to put points. ODE45 didn't have a problem in this case. So let's go back up to our definition of ysol, which was a long time ago, but here we go. And let's just put points here. So this now should be fine. So if I run this script here, and what we get is exactly what we expected. So let me share that with you. And you see how the figure number is changing each time. So now it's figure 3. The reason is because every time I run the code, it says figure of, and it creates a new figure. So let's just see this. So you see that the starred answers, the ODE45 is very, very close to the actual solution. The question is how close? So how about we zoom in and explore? just pick one of these. And you got to be careful because the width of this thing is going to stretch it out the curve. So I'm just zooming in a whole lot of times. And if I want it to get steeper, it's the shape of the rectangle. Aha, so you see that it's separated. So let us see. So what we can do is write down this number here. 1 point, maybe not write down. We see is that, let's just look at how many decimal places are right. So the graph at 0.9 is about this number here, the third number from the bottom. And where do they differ? They differ between, there's a 3995 and a 4005. So the decimal places are right for 1, 2, 3, 2, 3. So 5 decimal places, they're correct, which is pretty good. And it's the kind of thing that when you zoom out to a reasonable scale, you can't even tell the difference. So let's go back to MATLAB and see this more specifically. So first of all, in order to find that value that we had, so the value that we zoomed in on is, fortunately, I do not remember what the number was. It's being recorded, but I can't remember. It was, I think it was 0.9. I think that was the point. So let's look at T-list. 0.9 is this one. Unfortunately, I don't remember what entry it is. So let's see. That's not quite right. 0.9, so maybe 39. Okay, so T-list, 37. That's the 37th entry. Now, if I'm going to find the Y value, I do Y list, which is all the numbers that ODE45 generated, and I plug in 37. So this is my number. And then I want Y solve, the actual solution. And I'm going to plug it in to that same T-list value. And I get a number that looks exactly the same. And the reason is because MATLAB's not showing enough decimal places. So I'm going to tell MATLAB that I want to see more. So I'm just going to run these lines again. And let's see. They agree up to the 5. And then they differ off of that. So what we got here is from the picture, we were able to zoom in because it's a nice plot. You're able to zoom in on it. But here you can actually see the numbers. And let's go back to normal format. So when if I run one of these numbers, they're short again. So the absolute value of the error. So this is going to be Y list of 37 minus Y of T list of 37. This is the absolute error. And what happened here? Oh, okay. So what happened here is I'm not allowed to, I have Y of it. Remember how I defined Y earlier to be symbolic? All the way at the top here. Because I wrote Y instead of Y, it's not understanding. It's treating this symbolically. It's not plugging it in because it doesn't know what Y is anyway. If I plugged in 37 here instead of T-list 37, you're going to get an error. I mean, it's not an error, actually. The reason is that YSol is this function, e to the t squared, basically. And if I plug in the number 37, I'm basically getting infinite. You got to be careful because this right here is the 37th entry of a whole long list of Y values that ODE45 calculated. And YSol needs to be calculated at that same value of T. 37 is not the same value of T. So that's why we have to go back to our original thing we had, but with YSol. Okay, and here is the error that we got. This is the error to the 37th entry. So this is about e to the, 10 to the, sorry. So just having trouble wording it. So if you have this number here, that's 8 powers. So let's look at the numbers again. So although they differ here, this is 399 and this is 400, which is also very close. And then there's a 3 afterward. And so it's actually this spot where the error actually is, where the big difference is. So how many decimal places? That's 4 here and then 4. So that's why there's a -8. So here we got to explore some of the ideas how to use ODE45 and also plotting it using the actual solution. So I thought that I would put that up. Hopefully it'll help you with the lab. So I hope you guys have a nice day and see you later.